Killing Burmese pythons in Florida is nothing new. The night hunts through the sawgrass, the cash prize python challenge every summer, the state-paid contractors working the Everglades levees with headlamps and bare hands. All of it for years. But recently, wildlife crews started testing something over the Everglades that looks completely deranged from the ground. On a quiet morning, a technician leaned out of the open door of a low-flying helicopter, reached into a canvas sack and began releasing dead mice into the treetops below. Hundreds of them, each drifting down on a little cardboard streamer so it would snag in the branches instead of dropping into the water. And every single one of those mice have something sewn inside it. That something is sitting in your bathroom cabinet right now. He wasn't going rogue, and it wasn't a mistake. He was running a plan that scientists spent more than a decade building on purpose. And the reason this might finally break the python has almost nothing to do with the poison itself. I'm Ambrose Wild. Stay with me because the real answer is stranger than the mice. Start with the number that broke everyone's confidence in the obvious fix. When you add up the hours across every agency working the Everglades, it takes them on average around 12 hours of human effort to catch a single python. 12 hours for one snake. Now weigh that against what a female Burmese python does in one nesting season. She can lay a clutch of 50 eggs, and the largest females found in Florida have carried close to 100. So while a contractor spends half a day tracking down one animal, one female in the sawgrass has already set up to replace herself dozens of times. That is the whole problem. The removal is linear and the breeding is exponential. And it gets worse because you cannot remove what you cannot see. A Burmese python's skin pattern is not decoration. It is essentially military-grade camouflage, tuned over millions of years to dissolve into exactly this kind of dappled, wet, grassy light. Trained biologists have walked within a few feet of a 15-foot snake and missed it entirely. Scent dogs walk right past them. So the pythons are not behaving like prey that you hunt. They behave like something closer to weather. You know they are out there, you can measure the damage, but you cannot point to where. Nobody can even agree on how many there are. The honest answer from the US Geological Survey is that a reliable population estimate does not exist yet, because the animal is too good at hiding to count. The guesses run from tens of thousands into numbers that wildlife managers avoid saying into a microphone. What everyone does agree on is the direction. Since 2017, hunters and agencies have pulled more than 10,000 pythons out of South Florida, and the invasion has not slowed. Every conventional tool hits the same wall. You cannot hunt an animal you cannot find, you cannot bait a predator that does not need your bait, and you cannot pour poison into the water because the water is the Everglades, and everything drinks from it. So a small group of researchers stopped asking how to hunt the snake and started asking a far stranger question. What if you could turn the food itself into the weapon? To see where that idea came from, you have to leave Florida entirely and fly about 8,000 miles west to an island that already lived through this exact nightmare with no map. That island is Guam. And the thing that unmade it was not a monster. It was a slim, mildly venomous, night-hunting reptile called the brown tree snake, and it arrived by accident in the late 1940s, almost certainly as a stowaway in military cargo shipped in after the war. For a while, nobody noticed, but Guam's forest birds had spent millions of years on an island with no snakes at all. They nested low. They laid eggs out in the open. They had never evolved a single instinct to fear a predator that climbs in the dark. because none had ever existed there. To the brown tree snake, the whole island was an unguarded pantry. By the 1980s, hikers noticed the forests were going quiet. A young field researcher named Julie Savage worked out why. It was not disease, and it was not pesticides. She matched the timeline of the birds vanishing to the snakes spreading across the island forest by forest, and published the case that stunned her field. By the time the science was settled, it was already over for most of them. 10 of Guam's 12 native forest bird species were wiped out. Some existed nowhere else on Earth, so wiped out meant gone, permanently. The songs and the seed dispersal and the pollination all switched off at once. And the snakes did not stop at birds. Brown tree snakes climb anything, and they cannot tell a branch from a power line. They bridge electrical equipment and short it out, so Guam started suffering a snake-caused blackout roughly every couple of days. At their peak, biologists estimated more than 20 snakes packed into every acre of jungle, among the densest ever recorded anywhere. So the US Department of Agriculture went looking for a weapon that could kill this one snake without poisoning the entire island. And what they found was almost absurd. The active ingredient in ordinary Tylenol, acetaminophen, turns out to be violently toxic to these snakes. A dose of just 80 milligrams, a fraction of one adult headache tablet, is enough to kill an adult brown tree snake. You obviously cannot scatter pills through a jungle. But you can tuck 80 milligrams inside a dead mouse, glue that mouse to a strip of cardboard and tissue built to catch in the canopy, and drop it from a helicopter into the exact vertical space where the snake hunts. The agency spent years and roughly $8 million refining that system. That same program also runs snake-sniffing dogs through outbound cargo and builds snake-proof fencing around Guam's ports, all to stop even one pregnant female from stowing away to Hawaii and starting the disaster over somewhere new. And it works. But notice the ceiling on it. Even after all of that effort, the mice never eradicate the snakes. They only hold the line. Keep that word in mind. Control, not cure, because it follows this idea all the way to Florida. So the obvious question wrote itself: why not Florida? The answer starts with why the poison works at all, because this is the part most people get wrong. Acetaminophen is not a nerve agent. In a human, your liver quietly disarms it, using an enzyme process that snakes simply do not have in the same way. Inside a snake, the drug converts the blood's own oxygen-carrying molecule into a form that can no longer carry oxygen. The animal essentially suffocates from the inside over a day or two, without a struggle. Which is part of why regulators ever accepted it. It is closer to a targeted metabolic off switch than a poison in the horror movie sense. Acetaminophen also won for a practical reason. As a common medicine, it had already cleared mountains of safety testing, giving it a regulatory head start a brand new poison would spend years and a fortune trying to earn. And here is the fact that turned Guam's snake weapon into a Florida proposal. Burmese pythons share that same metabolic blind spot. This is not a guess. Researchers working with the USDA and the University of Florida fed acetaminophen baits to young Burmese pythons in controlled trials, and the results were blunt. At 20 milligrams, a small share of the snakes died. At 40 milligrams, mortality jumped to around 85%. At 80 milligrams, The same dose used on Guam, it was total. Every treated juvenile died, and the researchers noted the snakes showed no signs of distress. On paper, the python has the same door, and acetaminophen has the same key. But read that finding carefully, because there is a trap inside it. Every one of those snakes was a juvenile. The lethal dose for a full-grown adult python has never actually been established, and the scientists who ran the trial said so plainly. That is not a footnote. It rewrites the strategy. A 16-foot, 150-pound adult python that swallows deer and alligators is never going to notice a mouse in a tree. And even if it did, nobody knows how much drug it would take to matter. So the plan that sounds like it targets pythons does not really target pythons at all. It targets one specific, narrow, easily overlooked version of the python. And that turns out to be the smartest thing about it. A hatchling Burmese python is a completely different creature from its parents, and not only in size. At around 2 feet long in its first year or two, it is roughly the same size as an adult brown tree snake, which means a mouse is not beneath it. A mouse is a perfect meal. So unlike the adults, which spend most of their lives in the water and heavy ground cover, juvenile pythons actively hunt small rodents, and they climb. They move up into low branches and vegetation, exploring, because at that size, the canopy is where the food and the safety are. Right now, scientists at the US Geological Survey are radio tracking juvenile pythons through Big Cypress, implanting tiny transmitters in hatchlings and following where they go, precisely to map that behavior. To know which snakes to target, you first have to know a python's life table, how long they live, how many survive each year, and the age they start breeding. Get that math wrong and you burn millions killing the wrong age class. Get it right and you have found the exact soft spot in the whole population. The young ones move constantly. They investigate. They test anything that might be prey, which means a baited mouse hanging on a cardboard streamer is not landing in random forest. It is landing in the exact size range, the exact diet, and the exact vertical zone of a juvenile python's world. Now put that together with the math, and you finally see the real weapon. It was never about killing the pythons you can see today. A female does not have to be hunted down if she never survives to breed in the first place. Kill enough juveniles, consistently, across enough of the landscape for enough years, and the adults you never caught simply stop being replaced. The population does not crash next month. It ages out and collapses over a decade, quietly, from the bottom up. That is the surprise the whole idea is built on. You do not fight the snake you are afraid of. You erase the one you would never even notice. If a breakdown like this is why you're still watching, take 1 second and subscribe, because this is exactly the kind of story I dig into every week. Now, here is where the plan stops being clever and starts being genuinely alarming. To do this across the Everglades and the wider python range, you are not dropping thousands of baited mice. The scale researchers describe runs into the millions, dropped repeatedly, season after season. And once you put millions of acetaminophen-laced mice into the most complicated wetland in North America, you no longer control what eats them. Start with the reassuring part, because it is real. That 80 milligram dose is tiny for anything much bigger than a snake. On Guam, wildlife officials calculated that a non-target predator would have to eat something like 500 baited mice in one sitting to reach a dangerous dose of acetaminophen itself. For a raccoon, an alligator, or a hawk taking a single mouse, the drug load is mostly a non-event. So the honest version of this story is not that the bait kills everything it touches. For most of the food web, the dose is simply too small to matter. But there is one glaring exception, and it happens to be the worst possible one. Cats. Not house cats specifically, the whole cat family. Felines lack the exact liver machinery needed to process acetaminophen safely, which is why a single tablet can kill a pet cat and why every vet treats it as a true emergency. And in the swamps of southwest Florida lives a cat with almost no margin to spare. The Florida panther, one of the rarest large animals in North America, has clawed back from the edge of extinction to somewhere in the low hundreds of adults, and no further. Its entire remaining range sits in southwest Florida, boxed in by highways and development, overlapping almost perfectly with the heart of python country. A panther is an apex hunter, but apex hunters are also opportunists, and a free, motionless mouse in low brush at dusk is exactly the kind of effortless calorie a big cat takes without a second thought. The dose that a raccoon shrugs off is not the dose a panther shrugs off. So the single most protected animal in the region is also the single most chemically vulnerable one, standing in the exact spot you would be dropping the bait. And it does not stop with the panther. There is a snake out there you actually want to keep. The eastern indigo snake is the longest native snake in North America. It is federally threatened and it eats other snakes, including young pythons. It is one of the few native animals that fights this invasion for free. But the indigo snake also eats mice, and whether it can survive a dose of acetaminophen has never been tested. Nobody knows. On top of that, a real share of any aerial drop misses the trees and lands in water, where fish take it, and the python's whole habitat is defined by water. Eastern diamondback rattlesnakes, cottonmouths, and native water snakes would all cross paths with the bait too. And the danger travels further than a single meal, because a squirrel that nibbles a mouse and survives can still carry the drug in its tissues. So an owl that catches that squirrel and feeds it to its chicks passes the dose down to birds with no tolerance at all. So the bait built to save the Everglades would be raining into the one part of the food web nobody can monitor. And here is the part almost nobody in this debate has heard, the twist that makes doing nothing just as frightening as doing something. When the pythons ate their way through the Everglades mammals, they did not just remove raccoons and rabbits and deer. They rewired an entire disease system. There is a native mosquito in South Florida that used to feed on a wide spread of medium and large mammals. But once the pythons erased those mammals, that mosquito had to feed on whatever was left. And what was left was rodents. Specifically, the hispid cotton rat. Researchers at the University of Florida measured the shift, and it is staggering. In 1979, cotton rats made up under 15% of that mosquito's meals. By 2016, in python country, it was more than 75%, while the blood meals from larger mammals fell by roughly 98%. That matters because the cotton rat is the main reservoir for something called Everglades virus, a pathogen that can cause brain inflammation in humans. In plain terms, the python invasion may have quietly funneled a mosquito onto the one animal most likely to spread a human disease. The snake in the sawgrass is not just an ecological problem anymore. It is potentially a public health one. And that reframes the whole question, because now inaction is not the safe, cautious choice. Letting the pythons win has its own body count, just a slower and less visible one. Ecologists even have a name for the mechanism behind it. A rich, varied animal community tends to dilute a disease, spreading a mosquito's bites across many hosts so no single reservoir ever dominates. Strip that variety out and you concentrate the danger into whatever is left. The python did not invent Everglades virus. It may simply have removed the buffer that was holding it back. There is a final wrinkle that makes the target itself harder to kill. Some of the pythons tested in Florida carry genetic traces of a different species, the Indian python, from old crossbreeding. And hybrids can inherit a wider tolerance for changing conditions. On top of that, these snakes soak up so much mercury from the Everglades food chain that the state actually warns people not to eat them. So the animal you are trying to remove is quietly toxic, possibly adapting and breeding faster than anyone can count. The pressure to try something drastic is not irrational. It is the honest weight of a problem that keeps getting worse. None of this is theoretical, because other countries have already run the experiment of dropping a selective poison across a wild ecosystem, and the lessons are not comforting. Australia spent decades using a compound called 1080 against invasive foxes, cats and rabbits. It worked in one clever way. Many native Australian animals had evolved alongside plants that naturally produce that same toxin, so they tolerated it while the invaders did not. Populations of native species genuinely recovered. But alongside the wins, eagles died from scavenging poisoned carcasses. Some native birds turned out to be sensitive after all. Monitor lizards died eating the bait. And over time, certain rabbit populations began developing resistance. The target was adapting to the very weapon meant to erase it. The lesson is not that the poison failed. The lesson is that no large intervention in a living system ever produces only the effect you intended. The collateral is not a glitch. It is a feature. Then there is the human factor, and Florida has already shown its hand. A few years ago, a biotech company released genetically modified mosquitoes in the Florida Keys, engineered so their offspring would die off and crash the disease-carrying population, with no chemicals at all. The science was sound and had already worked elsewhere. The public reaction was not sound. Residents held signs about Frankenstein mosquitoes, filed lawsuits, and packed meetings with fury. And that was over an insect that bites people and that nobody loves. Now imagine the town hall where an agency proposes dropping millions of poisoned mice from helicopters across the Everglades into the home of the panther, the eagle, and the indigo snake. The scientific objections and the public objections would arrive on the same night. And the uncomfortable truth is that even the researchers who most want this to work cannot fully promise it is safe, because a landscape-scale drop against pythons has never actually been done. So what is holding the line right now? Not the mice, not yet. The tools working today are slower and stranger. There are scout snakes, sometimes called Judas snakes. Male pythons fitted with radio transmitters and released, then followed straight to the breeding females they find during mating season, which lets a team remove a dozen snakes clustered around one female that they would never have located otherwise. There are detection dogs that can scent a python hidden in grass a human would walk straight past. There is research into pheromone lures built from female python scent, and into diseases that might one day target pythons alone. Not one of them is fast, cheap, or ready at the scale this crisis actually needs. And none of them has the brutal, helicopter-simple appeal of dropping bait from the sky and watching a population quietly age out. Which is why the mice keep coming up. That technician leaning out of the helicopter over the sawgrass was not part of some rogue scheme. He was one small, careful test inside a question the state has not answered, and may not be able to. He flew home not knowing whether a single mouse he dropped had reached the right snake or the wrong animal. And somewhere in the grass beneath him, a female python sat coiled around a clutch of eggs, holding them at exactly the right temperature, afraid of nothing, with no reason on earth to be. Here is what should keep you up at night. Everything you just heard assumes the pythons stay where they are. They may not. There is already evidence that these snakes are becoming more cold tolerant, and the models of where they could survive keep creeping north, well past Florida. That is the next story, and it is a bigger one than this. I'm Ambrose Wild. Subscribe and I'll take you there next, because this invasion is not finished spreading, and neither am I.